If you happen to measure the voltage across a battery, the voltage stays constant. A 1.5 volt battery will provide 1.5 volts constant until like the cells are exhausted or like dead. And the current for a given load is going to be proportional to the voltage. So for a given load, that is going to be constant as well. If the current and voltage is constant, the power is going to be constant too. And this type of circuit that uses battery or some other sources where the voltage stays constant is called a direct current circuit. On the contrary, we have another kind of circuit called the alternating current circuit. Here, the voltages will be changing its direction. For example, if you happen to put an oscilloscope across or like a meter across the socket's neutral and live terminals, you will see the voltage changing its direction 60 times a second. And that is called the frequency. So it's 60 hertz, and that applies to North America. If you happen to visit Europe or Asian countries, you'll be able to see the frequency to be changed to 50 hertz. And this kind of circuit is called alternating current circuit. So why does it alternate? Is there like a reason for that? So most common type of alternating current circuit is the sinusoidal type of circuits. So let's compare AC and DC. So the circuit here is a alternating current circuit. So this is how we represent a battery, and this means this is a DC circuit. So we have an ammeter to measure the current. So the current and we have a voltmeter to measure the voltage across. And if the voltage is constant, so here in this case it's a DC, the voltage is going to be constant like that. And if that is constant, the current is going to be constant too. Of course, the amount of current is going to be dependent on the load, on the resistor, which we will see in the next session. But again, it's going to be constant anyways. And if these two are constant, the power is going to be constant. However, with the alternating current circuit, so this is how we indicate the alternating current circuit. So it is going to be varying with time. So a common type of alternating current is the sinusoidal wave. Why is it sinusoidal? Is because of the way the generator works. So for the generator to work, so this is a simple generator. So you have a magnetic field. So the way voltage is induced in a circuit is when you have a conductor that moves across the magnetic field. When you have North Pole and South Pole, you have a magnetic field that passes through. And when you have a conductor that moves in a direction, so based on the amount of flux, so these are called the flux lines or the field lines, based on how many lines it cuts per second, the voltage will be induced across those conductors. So that in a so it's not going to be linearly moving. So in a motor, in a generator, if you see, the conductors are not going to be moving linearly. It is going to have an angular motion. So that's why we have the angular frequency. So if this is another representation of the same, a 2D representation, north and south. So you have the magnetic field lines from the North Pole to the South Pole. So what happens is, like, when it is zero, so you don't have any magnetic lines that is being cut by these conductors. If you see, it is moving parallel to the magnetic field lines. So there is no voltage induced at this point. So that's why it is zero. But when you slowly increase, then like it is cutting few lines. So that's why like the voltage is slowly increasing. And when it is at its peak, so if you see, slowly the number of lines it cuts will increase sinusoidally. So it goes to the maximum at this point, because at this point it is moving perpendicular to the magnetic field lines. So it is going to be the maximum. And then when it comes back, it is going to slowly reduce, or like it'll greatly reduce at first and like then slowly reduce, and it comes back to zero here again. And now it's going to be the other way around. So the voltage is reversed, and here it is going to be zero again, and the voltage polarity will reverse. So if it was like plus 2 volts, it's going to be minus 2 volts. So, and it starts by slowly increasing, going to the maximum, and then coming back to zero. So all the alternators we have, or like the generators we have, by the way, an alternating current producing generator is called an alternator. So that's why the generator in the cars are called alternators. So all these machines have they rotate. The rotors rotate in an angular with an angular frequency. Based on that, the waves are going to be sinusoidal. So there are like other waves like that we use in electronics, but like those are all like produced with electronic circuits. But like this is the only way we produce electricity when we try to convert mechanical energy into electrical energy. So that can be power produced in power plants. So the way we produce power plants is like we use coal or nuclear reaction or something like that to produce heat. The heat heats up the water. The water is converted into steam. That steam is used to spin a turbine. That spin will be that the turbine has a shaft, and the shaft will be connected to a generator like this. And as the turbine rotates, the rotor of the generator will also rotate, and that's how we produce it. So that is the thermal power plant. Like this applies to wind energy as well. So when the fan blades spin, and that will spin the generator as well, and that will produce alternating current. The only difference, or like say the sources, say PV, photovoltaic solar cells, they produce DC current directly. So apart from that, pretty much everything else, like where we use some form of heat or like say wind power, all those are producing energy with alternators. So that is why it is sinusoidal. And let's see some of the way we can describe alternating current. So alternating current can be defined using two parameters, technically three, but like again, like mostly the waveform is going to be sinusoidal. If we kind of assume that it's going to be sinusoidal, so there are two parameters that is required to define a alternating wave. So one is the amplitude. So what is the maximum voltage, or like it can be voltage or current. So what is the maximum? So that will be the amplitude, and period will be the time it took to complete one cycle. So that is the two important parameters to describe an alternating current. So frequency, as I mentioned before, 60 Hertz for North America and then 50 Hertz for other countries. The unit of frequency is Hertz and the symbol is Hz, and Hertz is defined as the frequency of 1 cycle per second. So here, if you wanted to calculate the time period for 60 Hertz, then like we just use this formula. Time period is going to be equal to 1 divided by 60. So that's going to be the time period. Or if the period was given, you just like switch that and then like calculate the frequency. And here is a problem for you to solve. So the frequency of mains is 50 Hertz. What is its period? You can use the formula from the previous slide and then you can solve that. The microwave bleave has a frequency of 1000 Hertz. What is its period? So you can also use the same formula and calculate that. And that should be alternating current. And in the next session, we will talk about RMS value and why that is important.